Welcome learners. I am Dr. Ramuda from School of Management, Sastra University. I welcome you to the session Economic Ordering Quantity and Economic Batch Quantity. Economic ordering quantity refers to the quantity ordered and to be purchased at the total cost kept at the minimum level. This is the most economical purchasing quantity which will minimize the cost of ordering and cost of carrying. The cost of ordering can be otherwise called as procurement cost and cost of carrying may be called as holding cost. Ordering cost includes the cost of placing the order, then raising the order and follow-up. Carrying cost includes the cost of carrying the inventory in the stores, the cost of holding the inventory in the stores, namely the salary of the storekeeper, the lighting facilities, the insurance, the safety and security measures for the stores, etc. Now the economic ordering quantity is a quantity which is going to have a balance between the ordering cost and the holding cost. Economic ordering quantity can also be called as economic lot size. Now this quantity to be ordered at a particular time will be determined by this ordering cost and holding cost of the inventories. Now when the ordering cost and carrying cost are equal, then that is the point where the EOQ will be determined. When the ordering cost and carrying costs are equal, the total cost comes to the minimum. We shall now see to the graphical illustration of a EOQ. On x-axis we will have the quantity, on y-axis we will have the unit cost. Now the ordering cost will be lower when the number of units are higher. Say for example, if an organization needs 10,000 units per annum, the entire 10,000 units is purchased in a single lot. There will be one order, and if the ordering cost is 500 per order, now the ordering cost is maintained at a very low level as 1 into 500, 500 rupees. Now, if the annual requirement is ordered in 10 orders or purchased in 10 orders, then 10,000 by 10 will get 100 units per order. Now, the cost of holding 100 units is very less, but the cost of holding 10,000 units is high. Now, number of orders is 10 into 500 per order, so it comes to 5,000 rupees. Now the ordering cost increases and the holding cost decreases. So as and when the number of orders decreases, the number of units to be held in the stores will increase. So the ordering cost curve or the procurement cost curve will always slope downwards and the carrying cost will slope upwards. And the total cost will be the total of procurement cost and the carrying cost. The minimum point at the total cost will be the intersecting point of the carrying cost curve and the procurement cost curve. So the minimum point in TC curve and the intersecting point of this carrying cost and procurement cost curves is the economic ordering quantity. So this is the graphical representation of the EOQ. Bulk buying normally reduces the frequency of ordering and therefore the ordering cost is also reduced. The determination of this EOQ normally aims at balancing the ordering cost and the carrying cost. EOQ can be determined in the following formula. Square root of 2 into annual consumption in units into cost per order divided by price per unit into carrying cost expressed as a percentage of total investment in inventory. Based on the brief description of EOQ, let us now pass on to the EOQ assumptions. The model is based on the following assumptions. Annual carrying cost per unit and the cost per order can be accurately estimated and are said to be the relevant costs. This assumption really requires that all the cost information must be known certainty, which is said to be rarely possible. The annual demand can be estimated and it is linearly consumed by the customers. This assumption requires the annual demand estimate to be known with certainty. We all know that annual demand estimates can seldom be known with certainty because the annual demand of the materials will definitely depend upon the production budget, and the production budget will depend upon the sales budget. Sales budget is said to be the constraint of any organization because the sales will be predicted only from the market. Based on the sales budget, the budget for the production will be prepared, and based on the production, the material consumption budget will be prepared. So the annual demand for the materials cannot be known with a certainty. And again, this assumption requires that there is a linear consumption of inventory. The linear consumption of inventory is not possible in case of industries. Linear consumption can mean an uniform rate of consumption in the industry throughout the year, but that is not possible. As the order for the finished goods, that is the market for the finished goods changes, the rate of consumption of the materials will also change. Say in case for the first 3 months the rate of consumption may be high and the next 3 months the rate of consumption may be low. So we cannot say that there is a linear consumption of this inventory all throughout the year. This independent demand inventory is usually ordered by the customers in finite lot sizes or the order quantities, producing a step-like consumption function. Now this average inventory level is the order quantity, and that is to be divided by 2. So average inventory level is total ordered quantity divided by 2. This assumption requires that only an amount of Q inventory can be available. Suppose if we have a safety stock left in the industry from the previous period, definitely the average inventory will be more than Q by 2. So the ordering quantity must be divided by 2 and we say that it is the average inventory. But this is not possible in case of industries wherein the buffer stock is maintained. With the demand linear and certain, there may not be any stock out cost. This assumption basically prohibits the stocking out of inventory, as costs are always associated with being unable to meet the customer's demand requirements. If the stock out is not possible, there will not be no stock out cost. There are no quantity discounts on large orders. And once again, as the lead time is known, fixed and independent of demand, the inventory has only one stock point, and this stock point is said to be the location of inventory. So these are the basic assumptions of EOQ model. That is, annual carrying cost per unit, cost per order can be accurately estimated. Then annual demand can be estimated with a linear consumption. Then average inventory level will be ordering quantity by 2. then there will not be any stockouts, because we have a certain demand and a linear consumption. We will not have any stockout cost, and there will not be any stockout positions or circumstances, and no quantity discounts will be received on large orders, and the lead time is definite, and we have only one stock point. Now we shall see what are the weaknesses of this formula. The first and the foremost weakness is the erratic usage. We assume that the usage of materials is both predictable and evenly distributed, but this is not the case in reality. So in reality, the formula may become useless. There may be some other formula which can be developed for usage, because we have the varying demand for the materials. Then faulty basic information. EOQ can be said as accurate, as the ordering cost and the carrying cost information are said to be accurate. But this is not possible in reality. Ordering cost cannot be easily calculated, and once again the carrying cost will also change according to the opportunity cost of capital. So this ordering cost and carrying cost cannot be predicted accurately, as this cannot be predicted. Once again, the EOQ calculation will also be based on assumptions. And once again, this is not an easy job to estimate the cost of acquisition and cost of possession in a very accurate manner. This will require a high-skilled cost accountants. Actual calculation of EOQ may be time-consuming, even when a simple formula for safety and a steady usage are used. More elaborate formula is said to be expensive. In many cases, the cost of estimating the cost of possession and cost of acquisition and calculating the EOQ exceeds the savings made by buying that quantity. This EOQ ordering may be tempered with judgment. There are certain corporate goals to be followed in managing an inventory. Sometimes these guidelines may also provide a conflict in ordering the materials. Where order strategy conflicts with an operational goal, this order strategy restriction should be developed to permit the honoring the goal. The EOQ restrictions may include the following. The items purchased to order and items subject to rapid product improvement will be restricted from this EOQ usage. The shelf life items should be restricted to a limited quantity. Items with unusual sales will be identified, with annual sales reduced by the appropriate quantities prior calculating to the EOQ. The critical supply items should also be considered, and the time of supply of quantities should be selected, and this may override the EOQ. So these are all the basic weaknesses of this EOQ formula. Next we shall see what are all the precautions that is to be taken while using this EOQ. Now we shall see the precautions in using the EOQ. First one, the costs are not the same. While applying the EOQ, it is observed that the cost of the components are not the same for all items and all supplies. In case one order has many deliveries, the cost can be computed per delivery. But here, the order for the cost, that is the cost for this first order, is certainly not the same as that of the repeated orders for an established vendor. One order may contain several items, and thus reducing the effective number of orders. For critical items, The organization banks upon several suppliers and so the number of orders are more. Low value items are covered by a contract with a single supplier. Although the receiving cost may be the same, one cannot apply an uniform rate for delivery cost since instruction and testing fluctuate in either direction. In short, the ordering costs are not the same for all the items and for all the suppliers. The inventory holding cost in an engineering industry depends not only on the value of the item but also on its weight, volume and the nature of the materials. There are special cases like impending rise in prices, the closure of suppliers' units, the changes in the policies, etc. So some vendors may give frequent deliveries, but many vendors prefer to deliver in bulk. In SCAS, the criticality of an item overrides all the considerations. There are instances when EOQ should not be applied. If the requirements are not regular, the technique of material requirement planning is used. In such a case, flexible ordering is followed depending on the master production plan. There are some of the objections which are raised against EOQ. Often the inventory holding cost and ordering cost cannot be accurately calculated and even they cannot be identified. EOQ is often an inconvenient number. It leads to the random orders so that the suppliers receive an irregular stream of orders. EOQ without due regard to the possibility of falling demand can lead to a high value of obsolescence in inventory. EOQ may not be applicable when requirements are irregular or when there is an impending price rise. This is the place where the human judgment should come in. Every decision depends upon the environmental conditions, mainly relating to the technology, the import policies, the changes in the customer's taste, etc. Every decision is to be taken on the merits of this problem, and EOQ formula cannot be applied in a blind manner. In most cases, mathematical calculation should be used as guidelines, but these cannot be taken as the practical consideration. The ordering in the packaging sizes may not be convenient. Say the supplier may be giving in gross or in multiples of 100, etc. Suppose if the EOQ comes to as 160 or 130, then these orders cannot be made, which will not match the sizes that are offered by the suppliers. Then the saving in the freight may be more than the compensating extra inventory carrying cost. So when the bulk orders are made, you may save it in the freight cost, but that may be compensated by inventory carrying cost increase. Then the routine procedure should be simplified. Instead of ordering frequently, you must go in for the ordering of materials as per the requirements. So frequent ordering may increase the number of procedures. The perishability of the material should also be considered. The perishable items and bulky items with a diminishing consumption cannot be ordered in a bulk manner. The seasonal articles and the marketing conditions of the seasonal articles should also be taken into consideration to take about a proper judgment for the purchase. Then the liberal discounts and the concessional freight rates may suggest the larger quantities, but the pros and cons of large purchases or the bulk purchases should be taken care of while the discounts are avoided. Then the policies of the nation, that is the exchange policies, the import and export policies, and the lead times, the procedure for purchase, getting the, orders, etc. for the foreign purchase should also be considered. So these are all the basic limitations and objections leveled against the EOQ.